In order to understand how the world around us works, we need a way of talking about randomness. So many events in life are outside of our control. We need a way to talk about whether an event is likely to occur or not. The language of randomness is probability. Probability is a numerical measure of the likelihood that an event will occur. Probability is important because it provides us a way of measuring uncertainty. Probability describes how randomness, or chance, or luck, operates to produce an event. Probability is the number of times that an event occurs out of the total number possible of events. The symbol for probability is lowercase p, and the p is in italics. Probability values are always expressed as a decimal on a scale from 0 to 1. A probability near 0 indicates that an event is very unlikely to occur. A probability near 1 indicates that an event is almost certain to occur. A probability of 0.5 indicates that the occurrence of an event is just as likely as it is unlikely. But because our little primate brains don't deal well with uncertainty, we tend to create rules, superstitions, and rituals designed to make us think that we have control of random events. One word we use for our superstitions is belief in luck, as in, I am a lucky person, and something about me influences the random world to act in my favor. Of course, science explains our superstitions and rituals as well. Or, as magician and comedian Penn Jillette said, luck is statistics taken personally. And don't feel badly. It's not just us. Pigeons are superstitious too, as psychologist B.F. Skinner discovered by giving pigeons random reinforcement of food. Whatever the pigeons were doing right before the food was presented became repeated stereotypical behavior. The pigeons would develop complex rituals based on random events, as if they could do something to shape the outcomes and get rewarded. B.F. Skinner made the pigeons superstitious, using random reinforcement. So we should not be surprised if our complex brains are even more in tune with spotting patterns, or sometimes even creating patterns where none exist. In real life, the terms odds, chances, and probability are used interchangeably. But in statistics, they all have specific meanings. Probability measures the likelihood that an event will occur. Odds are a numerical measure of the likelihood that an event will not occur. Odds are expressed in fractions or ratios, such as the odds of winning are 1 in 2. Chances are probability expressed as a percentage. You have a 50% chance of winning. There is another form of probability. It's not really mathematical. It's called personal probability. Personal probability occurs when you make an assessment about the likelihood of an event occurring based on your experience or judgment. You might say, there's a 75% chance that I can go to the movies tonight, depending on whether or not I finish my paper. It's really just a measure of your confidence in your behavior. A trial is each occasion that a procedure is carried out, each roll of the dice, each choice of a card, each sample of a population is a trial. The outcome is the result of the trial. Often the outcome will be described as a success or failure. So if you bet on red 23, then red is a success, 23 is a success, and everything else is a failure. Success is the hoped-for outcome. Mathematically, a success is the outcome for which we are trying to determine the probability. In its simplest form, probability is the ratio of desired outcomes divided by the total possible outcomes. And this is the formula for probability. P equals D over T, where D equals desired outcomes and T equals total possible outcomes. Let's apply this formula to a data set. In this case, we have the numbers 1, 1, 2, 3, 3, 4, 4, 4, 5, 6. Imagine that we are going to write each number on a poker chip and place all of them into a bag. We're going to pull out one poker chip at random. Before we calculate probability, however, we need to know what is the total number of possible outcomes. Because there are 10 numbers in our data set, 10 poker chips in our bag, the total possible number of outcomes is 10. What is the probability of choosing a number greater than 4? Well, how many numbers are greater than 4? Only 2. So the probability is 0.20. What's the probability of choosing a number greater than 2? Well, how many numbers are greater than 2? 7. So the probability is 0.70. Which one is greater? The probability of choosing a number greater than 4 or a number greater than 2? Because the probability of 0.70 is closer to 1 than is the probability of 0.20, you are more likely to choose a number greater than 2. So what's the probability of choosing a number greater than 5? Only one number is greater than 5. The probability is 0.10. What is the probability of choosing a number less than 3? 3 numbers are less than 3, so the probability is 0.30. And that is how simple probability works.